Hello everyone. Previously, let me introduce myself. My name is Nurul Ridhowati and my three last digit number is 085. So in this occasion, I will show you about my project of basic mathematics. The first is about inference and the second is about proving with basic technique. So let's check it out. We will check in the first part about inference. In general, we know 10 rules about inference and you can see in the table that I show. The first is addition, then simplification, conjunction, modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, constructive dilemma, destructive dilemma, and the last is resolution. So this is material that must be understood before we move on to the example question on the next slide. Let's go straight to the example problem. So you can show about question that we will discuss. I will read the question. It is not sunny this afternoon and it is colder than yesterday. We will go swimming only if it is sun. If we do not go swimming, then we will take a canoe trip, and if we take a canoe trip, then we will be home by sunset. Lead to the conclusion that research is we will be home by sunset. The first step that we can do is assume the statement of the question. So assume it is sunny this afternoon with P. It is colder than yesterday with Q. We will go swimming with R. We will take a canoe trip with S. And we will be home by sunset with T. So we will get hypothesis, negation P and Q. And the second is R, then P. And the third is negation R, then S. And the last is S, then T. And the conclusion that we will search is T. The next step, we can put the hypothesis that we got in the step and reason table. And step and reason table, you can see the slide that I saw. So in the first, we have hypothesis, negation P and Q. With using simplification, we will find negation P. And we have hypothesis R then Q using modus tollens with statement 2 and 3. We will find negation R. And we have hypothesis negation R then S. Using modus ponens with statement 4 and 5, we will find S. And the last hypothesis, we have S then T. Using modus ponens with statement 6 and 7, we will find step T. So we will search or we will find the conclusion T. So we can conclude that the statement is true. We will move in the next material about proof with basic technique. First, we will prove with proof direct or pembuktian langsung. So it's more clear like this. If we have an implication sentence for every x in the universe of conversation, if px then qx. So we have to assume that px value is true. Nah, so that the statement is called true if px is also true. So that we understand better, we will go straight to the example question. So I have statement that we will prove. You can see it in the slide that I saw. Prove it that if m is an odd number and n is an even number, then m multiple n is even number. So we will prove that m multiple n is a even number. The first step we have to do is analyze which is p and which is q to make the implication. In the problem, if m is odd number and n is even number, that is pmn, and m multiple n is even number, that is qmn. So we have for every mn is the universe of conversation. If pmn, then qmn. Knowing that m is odd number and n is even number, we'll prove that m multiple n is even number. Oh yeah, before that, remember that odd number the sign is 2t plus 1 and even number the sign is 2r. So we can write m multiple n equal with 2t plus 1 multiple 2r, and it is equal with 4tr plus 2r. We can break it down into 2 multiple 2tr plus r. Now from this we assume that 2tr plus r with s until finally we will get to s. You can see that the 2s is like the 2r or side even number, so 2s is also even number. Now we from the proof that m multiple n is even number if m is odd number and n is even number. And the second we will prove with contraposition. In general, we can say for every x in the universe conversation, if fx then qx. The first thing we have to do is change the implication into its contraposition. So we get the contraposition is for every x universe conversation of negation qx, then negation px. We will assume the negation value qx is true. Well, a statement can be said to be true if the negation px is also true. For further details, we go straight to the example question. Prove it for all real number x and y if x plus y greater than equal 14, then x greater than equal 7 or y greater than equal 7. From that question, we will find that x plus y greater than equal 14 is pxy and x greater than equal 7 or y greater than equal 7 is xqy. So from the implication we also find the contraposition statement, that is if x less than 7 and y less than 7, then x plus y less than 14. Knowing that x, y is real number and x plus y greater than equal 14, we will prove that x greater than equal 7 or y greater than equal 7. Previously, we found the contraposition, and it is if x is less than 7 and y is less than 7, then x plus y is less than 14. Assume x less than 7 is x equals 7 minus a, where a is a real number, and y less than 7 is y equals 7 minus b, where b is a real number. So we can write x plus y equal with 7 minus a plus 7 minus b. It's also equal with 14 minus a minus b, and it's equal with 14 minus a plus b. Now from this we can assume a plus b equal, because a is real number plus b is real number equal c is also a real number. So in the end we will find out 14 minus c, where c is a real number. 14 minus c is equal with x plus y less than 14. So statement if x less than 7 and y less than 7, then x plus y less than 14 is true. Now, because the contraposition is true, the implication is also true. So we can conclude that statement is x plus y greater than equal 14, then x greater than equal 7 or y greater than equal 7 is true. Maybe is enough for me. Thank you for your attention and see you next time.